Okay, so in this video we're going to be looking at the next little bit of simplifying surds. This is where we have surds as a sum, so they're going to be added and subtracted with each other. But to start off with, we're going to actually recall some prior knowledge, and that is when we are simplifying some algebra. So here I can see I've got 4x plus 6x minus x plus 2x. So the main thing is that my x is the same throughout. So that means I can collect all of those together because the letters are the same. And to do that, I've got 4, add 6, which is going to give me 10. Take away 1, because remember if there's no number there, that means it's a 1. So 10 take away 1 is 9. Plus 2, that is 11. So that means my final answer here is going to be 11x, because I can sort of plop that x on the end. And think about it this way. If 4 add 6 is 10, then 4x add 6x is 10x, and so forth as you carry on. And we're going to be using this idea here to help us with our surds. So if we look down at that first one, and what you'll notice is that it's not actually too different from what we have just done. I've got 4 root 2 plus 6 root 2 minus root 2 plus 2 root 2. So again, I've got that surd that's the exact same throughout. And I'm going to collect it all and simplify it in the exact same idea. So I've got 4 add 6, which is 10. Take away 1, because there'll be a 1 there because there's no number. Take away 1, 10 take away 1 is 9. Add the 2 is 11. So that means my final answer is going to be 11 root 2. So you can see here, it's really not that different from when we worked with our algebras before. So the moment you sort of think of it more like algebra, it can be a little clearer because a lot of people get thrown by the fact it is a surd. The main thing is, if your surds are the exact same, you can collect them all together and add the numbers that are present in front of it. So let's look at one more question quickly, highlighting that. So I've got 5 root 10 minus 8 root 10 plus root 10. So I've got 5 take away 8, which is minus 3. Add 1, that is going to be minus 2. So that's going to be minus 2 root 10. Unfortunately, it's not always going to be this simple. A lot of the time you are going to have to do a little simplification. So let's look at a few questions like that. So this first one here, I've got root 27 plus 4 root 3. Minus root 12, and as you can see on the right hand side, I've already listed out my square numbers. So the first thing we want to do is look at our smallest surd, and we want to think to ourselves, can I simplify this? So I want to look at my list and I think, right, can I divide 3 by any of these numbers? And given that 3 is smaller than my smallest square number, that means I definitely can't divide 3 by any of them. So that actually gives me a really nice hint for the rest of the question. Given that I can't simplify the 3, that means this 3 is going to be present in all my little bits of surds. So if I look at that root 27, I've got something times 3 is 27. Well, 9 times 3 is 27. And as we can see over here, 9 is one of my square numbers, so that is going to work. Then I've got something times 3, which is 12. Well, 4 times 3 is 12, and 4 is one of my square numbers, so that is going to work. And now I can begin my simplification. So I've got root 9, root 3, plus... And this middle one, I'm just going to be leaving alone. There's nothing I need to do with it. Root 4, root 3. Then square root of 9 is 3. So I'm going to have 3 root 3. Middle number just stays as 4 root 3 minus square root of 4 is 2. So now I'm going to have 2 root 3. And what we can see here is that this root 3 has managed to remain as a constant throughout. And it should always be the case. You never want to do anything more with that sort of constant surd once you have identified it. And so now we can easily collect these all together. So I've got 3, add 4, which is 7. Take away 2 is 5. So that's going to be 5 root 3. Okay, next one then. So I've got 8 root 6 minus 2 root 24 plus root 600. So again, I'll look at my smallest surd and I think, right, that's 6. Can I simplify it? And no, I can't divide 6 by any of these numbers. So again, that gives me a nice little hint that that 6 is going to be present in all my surds to help me with my simplification. Let's just quickly change that to that lime green. So 4 times 6 gives me 24, and again 4 is one of my square numbers. And 100 times 6 gives me 600, and 100 is one of my square numbers, so that's all going to work. Then I can start my simplification. At this point here, I'm going to stick in a little times sign next to that 2 just to sort of help me in a moment. So I'm going to have that root 4, root 6, plus root 100, root 6. So I've got 8 root 6 minus 2 times the square root of 4 is 2. Square root of 100 is 10. I'm going to neaten up that little bit of multiplication that's going on in the middle of my question. So 2 times 2 is 4. And then I can collect my like terms together. So 8, take away 4 is 4. Add the 10 is 14. So I'm going to have 14 root 6. And once again, we can see this sort of constant root 6 that just remains present, never changes. And it's just there to help us with our simplification at the very end. Sadly, a nice little surd like this root 6 and the root 3 here may not always happen. Sometimes you might have to simplify every surd. So we'll look at an example on what to do when you come across one of those questions. So here I've got root 45 plus root 20 plus root 80. So I would still do the same as before. I would always look at my smallest surd just because a lot of time it's easier to work with. And I would look to see if I can simplify it. So I'd look at that and I would know from instinct that I can definitely divide it by 4. So I can certainly simplify it that way. And I am just going to work through the process and you'll see why in a second. So 20 divided by 2 is 10. That's not a square number, so that's not going to work. 20 divided by 3 gives me a decimal, so that's not going to work. I skip 4. 20 divided by 5 is 4. That does work, so that's what I'm going to use. And at this point here, I'm going to look at this divided by 5 that I've just done. And I know that when I'm going to simplify my root 20, I'm going to have that 5 present in there. And I want to see if I can also have it present in my other 2 surds. So I'm going to see what happens when I divide these by 5 as well. So 45 divided by 5 gives me 9. That is a square number, so that's going to work. 80 divided by 5, if I did that as a little division sum, I would then get 16. That is a square number, so that's going to work. So that has helped me identify what my constant is going to be for this question and what my square numbers are going to be for each part. So working through, remember putting that square number at the front. So I've got 9 times 5 plus 4 times 5 plus root 16 times 5. So that's going to be root 9, root 5 plus root 4, root 5 plus root 16, root 5. So it's going to be 3 root 5 plus 2 root 5 plus 4 root 5. And collecting our like terms together. So I've got 3, add 2 is 5, add 4 is 9. So that's just going to be 9 root 5. So that is how to tackle these surds when they're as a sum. Let me know if there are any issues and good luck with the work.